Okay, here's another example with complex numbers. Okay, this example is saying z is a complex number such that the imaginary part of z is 2 and z squared is real. Find z. So we have to find a complex number where it meets this criteria. So the imaginary part is 2, but when we square z, we get a real value. Okay? So not that difficult. It may look difficult at first, but let's go through these steps. So we know the imaginary part of z is 2. So we can write z as so. Okay? Now it's saying that z squared is real. So if we square z squared, so we have to square both sides. Okay? Well, we get, what do we get here? We get x squared plus 4xi plus 4i squared. Now remember, I squared is -1, so we get x squared minus 4, okay, plus I 4x. Okay, so this is a complex number. Z squared is another complex number, okay? Now it's saying z squared is real, so that means the imaginary part doesn't exist in z squared. Actually, it equates to 0. So that, what does that mean? That means 4x. 4x equals 0, so we get x equals 0. Okay? So the complex number that we're looking for, okay, if x is 0, is just z equals 2i. Okay? And that's our complex number that meets this criteria. Okay, so not that difficult at all. On the next example, there'll be a harder question that involves, okay, the similar techniques.